So, as you would have learned in the previous lectures about the supervised and unsupervised learning, which was a part of machine learning, and so in that you must have learned about the classification and regression. That it is a part of supervised learning in which we try to train the model with the help of some data and its data and some labels. So we will be deep diving in today and learn about the regression. Okay. So what is regression? So basically, what regression or linear regression is that it is used to find a it used to train the model by training it on a certain data sets which contains some kind of input as well as output, and that input and output are continuous values. Okay, which means they are basically numerical values. They are numbers. Like for example, let's say if you try to buy some house anywhere in the world, so what are the things you need? Location and num when was the like number of rooms in the house, funny the area of the land in which house is built, and many other things. So all these values are numerical values. You have longitudes, latitudes are in numerical values, number of rooms, and amount of land that a house is built in. These are all numerical values. Okay. So when we deal with these kind of numerical values, we mostly go to a regression. Okay. Buying your house is a classic example of how to calculate the like housing price is the classic example of linear regression. Okay. In this, we will be using the module called scikit-learn, which is basically a one of the most used module for machine learning models. So let's just say uh, let's get started with it. So, like, how does this linear regression work? Okay, as I was saying earlier, the linear regression is a supervised machine learning algorithm used to predict continuous numerical values. Okay, then how does it calculate these? So, what it does is it's try to find a straight line relation between the input and output variables. What does this mean? Basically, if you're seeing on your screen, there is a equation called y is equal to mx plus c. Okay, so if you have learned some geometry in your class, you would easily able to recognize this equation. Okay. So let me and if not, let me just give you a clear visualization. Y is equals to mx plus c graph. Okay. So let me just go to images. Okay. Let's just say this. Okay. Let me expand it. Mm, just give me a second. Let me expand the image. Okay, we are going back to the graph. So let's just look the image from here. Okay, so let me zoom in. So this is the equation. Okay, y is equals to mx plus c. What m is here is slope. Okay, if you want, if you've learned some maths in your 10th class, you would like easily recognize this that uh, if we have to represent a line in a graph, then what are the things that we need to do that? Okay, first of all, we have y-axis, y value, using which we using that we calculate y value using x values. Okay, for that we need to need some kind of slope and some kind of constant, which is also known as intercept. Okay, so intercept is just a constant value. It will depend. we don't need to look into it a lot because it is just constant. And the another thing is called slope. Okay. So in the case of linear regression, what happened is we adjust this slope according to the x and y value that we use for training the model. Okay. We like adjust this slope so that the most of the points that are in most of the input points lay on this line. Okay. So that is what main uh, concept behind linear regression is. Okay. You need to find a slope where or m variable where this line will fit most of the points. Okay. Let's go back to the PPT. So there are two ways where we can write this equation. One, I show it to you, y is equal to mx plus c. But suppose now if we have more than one variable, okay, now we have x1, x2, x3, and many more. As I was saying earlier in the example where we are trying to buy the house, that if I want to buy a house, I need to look into number of factors. How many rooms are there in the house? What is the amount of land that is a building? What are the locations? That means latitude and longitude, and what kind of locality is in it, and many others. Okay. For that, we have multiple variables in that case. Okay. So for multiple variables, you can see on the slide. Just let me zoom in. Yeah. So you have that B is supposed to be a constant here. Is somewhat related to like C. It's a constant. There's a numerical value like 5, 3, 4. We don't need to like look into it. Now we will have the X B1 X2. So some like sorry B1 B2 B3 and so kind of many other kind of let's just say interpretation of M or slopes for each variable so that we can calculate the house price. Okay, it may sound a little bit complicated now, but it is one of the simplest thing in the machine learning. Okay, so as you can see the mathematical representation here, m slash b1 slope impact of x and c com b not intercept is basically a for error difference. Okay, like what is the difference between actual and predicted values? It's just a like constant. You most of the time you won't need to calculate it. Okay, it will just come uh, while training to it. Okay, all you need to like adjust is m. It's just the intercept error difference between actual and predicted. Okay, so let's go. Okay, so when do we use linear regression? So linear regression is suitable when the target variable is continuous, as I was saying earlier, which means all the time we have to just work with the numerical values. Okay, and there is a linear or non or near linear relationship. You want to measure the impact of variables and you want to make predictions of forecast. Okay, so with that means is like there's a somewhat linear relationship between linear or near linear relationship between like your result variable and your input variables. Okay, like as I was giving the example of house pricing, let's say like if one house has two rooms, it's a 2 BHK apartment. Okay, and if another apartment has three is a 3 BHK apartment, so it is obvious that a 3 BHK apartment will be costing more as compared to 2 BHK. Okay, so there is some kind of or a relationship, or I should say linear relationship between the number of houses and the price of the house. Okay, similarly if the like apartment is located in some kind of posh location, like you say in Delhi, like Saket or any other thing, mostly on the like yellow line part. So it will cost more as compared to if it's located in some another part of Delhi. Okay. So latitude and longitude come into the play. And all these are numerical values. And these follow some kind of relationship with each other, like linear relationship. Like if you increase one thing, then the other will also increase. Or if you decrease one thing, the other will also decrease. Or we can play with relation increase and decrease. So real world examples, like as I said earlier, predicting the house prices, and it can also use in sales marketing. Okay, and if you sales and or there are many more examples other than that. For example, forecasting revenue trends you can see on the slides, sales from marketing, house price estimation. So these are the some of the examples of the linear regression. Okay, and if the relationship is not linear, then there will be no useful linear regression model in that case. And somehow, if you think like, how will I know that whether the relationship is linear or not? You will just you try to make a like think about it. If the input variables which are causing the prices or not, with hiking the prices or in the result variable, then it's relation in then it's uh, linear. For example, the number of rooms in an apartment affect the housing prices. Okay, and it's not like if uh, you have 3 BHK and houses it's cheaper as compared to 2 BHK house. It may happen according to the different variables, but in at the end of the day, they are following some kind of linear pattern with it. For example, you can like put that uh, variables in the equation y is equals to mx plus c. Okay, just think of it like this. If you can put the variables you want to calculate in a relation called y is equals to mx plus c, then it's a problem of linear regression. Okay, and if you're not seeing that happening, then you might need to research more, like what kind of model can we use to predict the values in that use case. Okay, so we are now to the code, like what are the libraries and dataset. Okay, dataset, in that case we will be creating our own dataset. It will be a small dataset. Okay, so as you can see, we will use pandas and numpy, and we also use a library called scikit-learn, which is basically, if you write in the code, it will call sklearn. Okay, so we'll be going to the code, and this time we are trying to create our own data set. Okay, we are taking a data set where we will be calculating marks according to numbers of hours studied by a student. Okay, so I've already written the hours. I'm just write the marks in a second. A, E. Okay, if I have 10, then it should get 89 and 3, 34, 40, 43, 85, 90, 96, 9, 98, uh, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are at 20. Okay. And then we have 97, and if we get 14, we got, let's say, 88. Okay. So we will first creating like this is our just small amount of data. Okay. And we will be importing pandas as PD and creating this data set into Pandas data frame. Okay. So for that, we will be using df is equals to pd dot data frame and use t there. Okay. Now it's converted into data frame, which we can use. Okay. So it's a basically small data set just to show you the application of linear regression. If you want to work on some real world data, then you can go to Kaggle and you can apply the same techniques as I will be applying in this, or you can just directly refer the PPT for the code. It's basically work on the on that data set also. Okay. So now we will be from sklearn will be dot linear model import linear regression. Okay. And from that we will also import sklearn dot model selection import train test split. Okay. We'll be needing these two libraries, sorry, these two modules to showcase our linear regression model. Okay. So now what we will be doing first is to prepare the data for training. Okay. In this case, we just need to create one variable x, which will be df dot hours. Okay. And we will creating y. So df dot df marks. Okay, notice that here I use the capital X and small case y. So it is a general practice like we have to train like we have to like give the capital value to our training input train and labels we will go with lowercase y. Okay, it's not like mandatory, but it's better if you follow this practice. Okay, so now we'll be splitting the data for train and testing. It is a like in this data, we will use some part for training the model, and rest of the part that we split it will be used for testing the model. Okay. So for that, we will create variables called xtrain, comma xtest, comma ytrain, comma y underscore test. So xtrain is the input variables which we'll be using for training, and xtest is the input variables that we will be using for testing. Okay. Similarly, ytrain is the label other labels, basically output variables, which we'll be using for training, and ytest are the labels or output variables which will be used for testing the model. Okay. So go with train. We will using train test split, a module that we just import, and here we will give you giving the test size of 0.7. Okay. 0.7 means that the data will be, let me write out in comment, data will be splitted in 70 30, i.e. 70% for training and 30% for testing. Okay. Is it clear till here? Mm, what is the error here? Okay, I didn't give X and Y, sorry. Yeah. You need to also give the X and Y above, okay? X dot shape 0 chord scalar array 0.7 What is the problem? Mm, 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 mm. Is test size. So test size. Okay, think I didn't write test size. That's why. Y, comma, test size equals to 0.7 or 0.3. Okay. Yeah. So what I did here is I splitted the data and give a test size. Okay. Here we will give the size of the test size of the test data set, okay, which will be on the data set which will be evaluating our model. Okay. So this is a test size 0.3, which means that third of the data, like 30% of the data will be used for testing the model. Okay. And X and Y, you have already seen that it is nothing but the uh, data that we use for training the model. Okay. So till now it's clear. Okay. So we will be moving forward. Now, what we will do is to create a variable called um, which basically means linear regression, and we will be assigning a linear regression module here dot fit. Basically, we will be now training the data into like x train, comma y train. Okay, we are not training the data of the on this variables x training and y training, where it is, yeah, y training. A linear regression is a model, and now we're fitting the data on the x train and y train. Okay, now let's see the two class pass the data from containing single row or single feature instead. Uh, Let me just check what is the error here. X train. Okay. Mm-hmm. Okay, I think it must be issue of the index. Let me just remove the index. Okay. Extend the shape. No, it's fine. Why it's getting for two-dimensional container was class pandas for CVC. Let me check this. What kind of error? Why this coming? Okay, I got that. What was the error here? For that x, you need, if you are working with a single variable, you might need to use the x variable like this, because x in the linear regression fi- uses a double bracket for that. Okay, it when you try to like create data, use x for this, like use double square brackets so that it will take it as a data frame and not a series. Now let's run that again. Okay, and then directly run. Okay, done. Yeah, so model has been your trained. Okay, since it's very small amount of values, it will take no time in training the model. Okay, now we will try to predict the model. Okay, is it clear till now? Now we will trying to predict the values. Okay, for that we will creating a value of y underscore pred, and this we will give linreg dot predict x test. X test is the part or data set that we will be using for testing, that we split it here, as you can see in that column. Okay, so let us see the result of y pred. Okay, so these are the values. Let me also give you the x test. Okay, like what did value did we pass in the x test? X test. Okay, yeah. So these are the values that we passed on the x test. This one, like 17, 4 or 14. These are the hours, the number of amount of hours the student studied. Okay, and which it the model predicted the marks and gave us these marks. Okay, it is on the it is based on the data that we trained the model upon, these x-train and y-train. Okay, and let's see what are the real values that the what are the label real values actually are. Okay, okay, as you can see, other than the fourth value, it is giving very close result as compared to number of hours. Okay, so basically it is very close to the accuracy of the model. Okay, now if we try to calculate the accuracy. Okay, so basically up till now what we did is we created some random data, we converted into a pandas data frame and imported a linear regression model and train test split module to split our data set, and then we assigned x and y, disputed the data upon x and y, which is x is input variables and y is called labels. Uh, Input variables and labels. Okay. Then we split the date that x and y accord into four parts, which is basically training and testing data set. Okay. You have input variables of training data set, testing variables of input data set, training labels of the input data set, and testing labels of the input data set. Okay. And then we use the training data to train a linear regression model. Okay. Then What we did using the test data that we got earlier, we tried to like predict the models. We tried to get the models output, like how is it working, how is it predicting the data. Okay. Now we created a data. We created y pred value, which is basically predict outputs predicted by model. Okay. And we will try to compare it with the test labels which we got from our data set that we split it in the train test part. Okay. Now, up till now, everything is clear. Everything is clear up till now. Yuvik. Okay.
Yes, yes, sir.
Okay. Is any up till now any other doubts if you want to ask, like what if you are getting stuck anywhere?
No, sir, no, sir. I
Oh,
understand.
okay. So now that we trained our data, what we need is to uh, measure the accuracy of data, how well the model is trained. Okay. So for that, we will go to sklearn dot metrics import r to score. Okay. It is basically a metric. R square basically is called R square score. It is used to calculate the accuracy of a regression model. Okay. You also have multiple like mean squared error, R2 square, and another more other metrics functions. In this case, we will be using R square. Okay. So how to use R square? R score. Here we have to pass the values of testing testing labels that we got from splitting our data set, and we will get y predicted values. Okay, that we used to predicted that we that the model predicted. Okay. Now, if we run this function, we will get this code 0.9268 and this. So basically, R2 score, R2 score goes from 0 to 1. Okay. It is giving us 0.92, which means score of 0.92 means we are getting 92% accuracy. That means a model that we trained, this linear regression model, is 92% accurate in calculating the marks from the numbers of R's. Okay. So this is one type of calculating a one type of accuracy measurement. Okay. Or we can do from sklearn dot metrics import mean squared error. Okay. Now mean squared error is also a kind of performance metrics for regression models. Here, we will follow the same pattern, comma y red, oh, and it is giving us a value of 44. Okay, so what does 44 means? It means that it is a cumulative error. If I'm wrong, if I'm not wrong, It basically tells us the like what is the amount of cumulative error. Okay, so the lower the value of mean square error, higher the accuracy of the model and higher the quality of the model. Okay, it is like it will show you the average of square difference between tested and predicted value. Mean square error, let me show you the formula. It is you can easily like identify this error because it's basically very basic formula. Okay, this is a mean square error. Okay, what it does it takes actual values or in the data set which are data set values and predicted values which are predicted by uh, like predicted by the model, and it basically find the mean of these errors. Okay, let me give you the example here. For example, if I use y red comma y test. Okay, so these are the value. Okay, y pred we have 96, 40 and 88. Here we are getting 97, 51 and 86. Okay, so what will it will do is 97 minus 96, whatever may be the result, and 51 minus 40, where whatever the result will be, and it will square the error. Okay, similarly 86 minus 80. Okay, and it will square, it will add all those error and divide by number of values that we have. Okay, so it's basically this formula, this one. Or so lesser the value of mean square error, which means better our model, better the model is performing. In this data set, we only took 10 values, so it won't matter any, like it is just for the example's sake. Okay, so uh, these are the these are how we evaluate our models. Okay, you can use R2 square. R2 score I would prefer, like you would use more SMT mean square error because it is more confusing because basically not giving the accuracy but all, it is giving the loss how much, like how much error our model is giving, so it may like feels confusing sometimes, so better use R square. Okay, R square score. So let's go back to the PPT. Okay, so it contains all the steps that we did in while we were coding. So selected variables, we did selected the variables, then we split the data using test chain split. You can also use the random state variable here. It is basically try to hold the uh, splitting test. For example, let me show you what does random state do. It basically uh, what it will be do. It will like it will not let train and test data split. Oh, sorry, split in a randomized way. For example, if I rerun this entire code, you there are many much chances that you will get different y test value. Okay, let me rerun. Let's see. Okay, these are the same. These are the same. Let me just run this. Okay. Now if I go try to run y test, see now you get different values. Earlier it was 96 and 40 and 89 something. Yeah, now it is 98, 43, and 88. See the difference is there in the values. So what the see the difference in the values. So random state what it does, it try to hold the value. It does not let your data training and test data set change on every time you run the code from the start. Okay. So now also we go to step 3, which is train the model. Uh, model we called a linear regression model, and then we fit it on the X and Y thing, and then make predictions. Okay, you have all these steps in the PPT. Try to go according to the PPT and try to write these code at a single time. Okay, so that you get the habit. Now, what does the model output is giving you? Okay, now we get the output, but how do we interpret this output? Like I get the values, I got the marks. So, like, what is the inner working of the model? Okay, so what we do is like, uh, okay, these are the values I forgot to show you. Just let's go to the code first. Okay, so earlier I was telling you that entire linear regression model is based on the equation of, let me write it down. Okay, linear regression basically depends on the equation of y is equals to mx plus c. Okay, and that is what this is what this is the equation that the linear regression model here used to calculate and train the data. Okay, like it is the same equation that it used to train on the data, and it is the same equation that according to which your data is getting predicted. Okay, so now we will get two two variables which will be like yeah, what linreg, yeah, I use the name linreg dot coef, which is basically c, coefficient part. Okay, let me use print statement. And another one was linreg dot uh, intercept. Okay, sorry, I made a mistake here. Your the coef part is m. Okay, m is equals to coef, and c is equals to intercept. Okay, you can call it coef or slope. It's your choice. Okay, so let me just. Okay, so 3.51. This is our slope m, and 37.37 is our intercept. So what the linear regression model did is that after training on the data, what it did, it basically used the equation called, it basically created your y pred value using this. Okay, model.coef, which is basically for of 3.51, let's just say 51 into x, whichever your training data is, or let me look write it like that, x test plus your intercept, which is 37.37. So this is how your model calculated your y pred value here. That you are seeing the y pred value, yeah, this one y pred value 97, 51, 86. This is how your model calculated those values. Okay, so it is what happening in the behind the scenes of the model. It is basically running this simple equation to predicting the values. And where does this values come from? It came from uh, it came from your training the data. Okay, while it was training, it saw like there are seven values here. It saw like what is the calculate, what is the output is coming, if the output is coming correct or not. And if it's coming correct, then MSC is, uh, let me like show you by writing. Okay, suppose let me use Markdown for this. Okay, suppose we have, let's take a value from training. Let's say this. I'm taking very first value 10 comma 89. Okay, we have x is equals to 10, and our result should come, which is equals to y is equals to 89. Okay, so now linear regression model will give some random values to m and c at the start date. Okay, so it will look around like 89 is equals to m. Let's just say it gave m value is, let's say 2. Okay, and give the value c, which is intercept, let's say 13. Now what it did is saw like that, it saw like whether I'm getting this 89 value or closest to 89 by using this slope and uh, this intercept. If I'm getting closer to the value 89, then M and C are correct. And is if not, which is basically if I try to calculate here, actual value would be 10 into 2 20 plus 13, that is equals to 33. So see, we are nowhere close up to 89. So what it did, it tried to increase the value of M and C to see whether now I'm getting closer to the value of 89 or not. So it is like testing the value of M and C again and again, again, again on that data, training data. The model come to the final result, which is 3 point, 3.51 and 37. Okay, it is these value, at these values the most of the data points uh, will be fit according to the model interpretation. Okay, at these value you will get the result, at the most accurate result you will get the most so this is how the internally model is working. It is constantly try to work around the value of MNC, like on at which value it may get the result. Okay, so this is the inner working of the model itself. Okay, so we got coefficient, like how much y changes when x increases by 1 unit. Okay, if y comes to 890 instead of 80, then, oh sorry, let me reverse that. Like if x go from 10 to 11, then how much changes that's y on result label happen. Okay, so that is will be as a slope. And intercept, what will happen like basically is what is the value of y when x is equals to 0. In our case, which was number of hours according to the marks. So if a student does not study at all, how much marks will it get? How much marks will he get? So according to the model, the mark that he will get is around 37. Okay, it is basically a slope. It is basically intercept, like on value of x is equals to 0. If I use x is equals to 0 here, m by x, which basically means m into 0 is equals to 0. All we have left is the intercept, which is 37. So on if a student even doesn't study for a single hour, he will get 37 marks. Okay, so that is the intercept. Okay, so and the prediction, estimated output for the given input, which is basically we predicted, basic, which is basically bipred variable. It is a prediction on the basis of value given by us to the model. Okay, like if we give, I will ask the model, suppose a student studied for 7 hours, how much marks will he get? And model says like around 50 to 63 marks, he says. So model gave us the output, which is prediction. It's not like certainty, like the student definitely will get 63 marks. It's a prediction. Okay, it's a probability of getting 63 marks on studying just 7 hours a day. Okay, so now uh, evaluating model that we use R square for R square test for. So what we did, we got the R square value of 0.92, which makes a model strong. Model called we have a model quality strong, like we have a good model. Okay, we can use that model to train other values. Okay, now how, let me just visualize, let me show you by visualizing so that you can better understand. Let go to the code. Okay, I will use plt dot scatter. Let me just spell. So from matplotlib dot py, not from, import matplotlib dot pyplot as plt. Okay, now import, I will scatter x comma y. Okay, now let's see. So it is a data. Okay, this is our data on the visualization aspect. Okay, now what is the main purpose of linear regression is plt dot plot x comma y, not like this, lin dot predict. We are basically predicting the values again, but this time on entire data set. Okay, plt dot x label, which is ours, and plt dot y labels, which is uh marks. Yeah. Okay, now if I do plt dot show, okay, like x labels. Okay, why is this error icon coming? Yeah, nice. So let's see. So what is the main purpose of this line? Let me just give it a different color. Uh, let's see whether works or not. Yeah. So this is red line is the predicted value. Okay. And these small blue dots are the actual value. So what is the purpose of this line is to give us a slope and intercept where all these points come closer to it. Okay, so as you can see, these 2 points are way closer to the line. This basically touching them. These are points are also that are a little bit closer. These are also there, closer. So the purpose of the linear regression model is to find the where slope and intercept, where all these points can be to the can be closest to the line. Okay, can be the most closest to the line. Now, if we get different slope, the line will go up and down according to the slope. If you able to visualize, if you study 10th class geometry, you will be easily able to visualize that. Okay, so main purpose is of linear regression model is to find the slope and intercept, basically find the M and C, so that it can so that this line will be situated in the way, visualization where it will be closest to the these data points. Okay, so for example, like on setting 12 point hours, the model will give you the red line, which is like according to model, the value would be 80. Okay, that point will be situated in that line, but the actual value is around 90. So we need to make sure that the difference between difference between the 80 and 90, or difference between the values, should be minimum. Okay, we can't like overlap the entire line. It will basically means overtraining, which is bad. Okay, but we need to reach the closest to the actual data point. That is how all the machine learning models, deep learning models, and uh, machine and deep learning models work. Okay, we need to go to the closest to the value, reduce the amount of error. Okay, so that's how linear regression works. Now, what you need to do is uh, l- take some data set and select one x variable and one y variable, that like we did in this code during the lecture. Build a linear regression model and print the coefficient, intercept, and R square score, and plot this scatter plot in regression line like we did here. So basically, you have to rewrite this entire code. Okay, and that is your assignment. So we have reached the end, and we have gone 1 minute extra. Sorry. So let's just